A certain type of bacteria, given a favorable growth medium, doubles in population every 3 hours. Given that there were approximately 25 bacteria to start with, how many bacteria will there be in 2 days? Okay, so first of all, this is continuous growth because it's bacteria. It doesn't explicitly tell us that in the question, but we can assume that. So we're going to be using the formula A equals P naught, the initial amount, times e to the kt. Now, we could technically calculate this just by doubling these for a total of, or doubling the 25 bacteria about 16 times, something like that. Because it's doubling every 3 hours over 2 days. But we can figure this out easily using mathematics. So the first thing to note is that it doubles in population every 3 hours, which means that the initial amount is going to double or become 2 after 3 hours times 3. So essentially, we can use any numbers we want here instead of 1 and 2, but the idea is that this has to double to become our secondary value, essentially, because after 3 hours, this amount right here is going to double to become our final amount. All right, so we can start with whatever numbers we want, of course, but we'll start with 2 and 1 because those are really easy to use. This just becomes 2 equals e to the, let's write this as 3k instead of k times 3. And now we can use logarithms to solve for this. So we can take the ln of both sides. We want to do this because ln and e are inverses, so they will cancel. So ln of 2 is equal to ln of e to the 3k. Now there's a property of logarithms that allow us to bring down the exponent. So this is, again, rewritable as ln of 2 is equal to 3k ln of e. And remember that ln of e is simply 1. These cancel out. So we're left with ln of 2 equals 3k. Now to solve for k, we simply divide both sides by 3. And this gives us that k is equal to ln of 2 over 3. Or, if we plug this into our calculator, this gives us about 0.23. So what we just solved for is the growth factor, right? How much it's growing essentially per hour. And it's growing by about 23% per hour here. So let's go ahead and solve this. I'll just sort of break this up a little bit. We want to know, if there were 25 bacteria to start with, how many bacteria will there be in 2 days? 2 days is equal to 48 hours. So that's what we're going to be substituting into our time, t. In other words, we have A is equal to the initial amount, 25, times e to the kt. Remember that k is 0.23. And we'll put these in parentheses to not confuse the decimal point. And this is going to be 48 hours because that's the total number of hours that we are growing for, essentially. So now we just plug this into our calculator, 25e to the 0.23 times 48. And this gives us a very, very large number, approximately, let's see, how many digits is this? 1 million, so 1,557,941. It wants to know how many bacteria there are. Bacteria is a unit. It says approximately 25 bacteria, which is a little confusing, but bacteria are units of things, so we probably want to round down in this case. So we'll just keep it as this, 1,557,941 bacteria after those 2 days. Okay, I hope that makes sense. Thank you for watching. Please go to my Instagram, follow that, subscribe to my YouTube channel for more content, and feel free to send me in your questions, which I will solve on YouTube or on stream on Twitch. Thank you. Bye.